Hi folks, we're continuing with some Chapter 3 homework problems, and here's number 12. Doctor Who and his trusty companion visit the planet Splat. They climb to the top of Mount Crumpet and throw a ball horizontally off the top of the mountain, which is 1,200 meters above the flat plains below. If the acceleration of gravity on Splat is 2.9 meters per second squared, how many minutes pass until the ball hits the surface below? Okay, well, let's draw ourselves a picture. So here is the surface of Splat. Here is Mount Crumpet. We'll put Doctor Who up there. We'll give him a little fez for the Doctor Whovians out there, and he's going to throw a ball off the top. Now it's horizontally going to go like that. Now we know the mountain is 1,200 meters high, so 1,200 meters high. So what distance is that? That is going to be vertical. Remember, horizontal and vertical information. So vertical displacement is 1,200, did I say 100,000 meters. The acceleration of gravity on Splat is 2.9 meters per second squared. So we're no longer on planet Earth. We're off around the universe with the doctor. And we want to know time until the ball hits the surface. So time, we do not know. Now, if he throws the ball horizontally, we know the original vertical velocity is going to be 0. Horizontally, the horizontal stuff, what do we know? Well, we know, we don't know diddly. We know not much of anything. So we got to figure this out, don't we? Let's go ahead, and we know that, which is the height, and we know the acceleration of gravity. Original vertical velocity, time. I'm having this feeling that maybe we don't have to use the horizontal stuff. Let's go ahead and solve for what we know. So what equation does all of that lend itself to? The old good old drop equation, x, which can be y, is VOT plus 1/2 AT squared. If the original vertical velocity is 0, that goes to 0. So y is 1/2 AT squared. We're looking for time. Time is going to be 2 times y divided by acceleration square root of the whole mess. Holy moly, we don't need all the horizontal stuff. We're going to get time in one easy step. 2 times 12,000 meters. I don't know, I got hundreds on the brain. Sorry, guys. 2.9 meters per second squared. And when I solve for that, let's see what I've got. 2 times 12,000 divided by 2.9, square root all of that, and I got 90.97 seconds. Okay, but the question is minutes until it hits the ground below. Get rid of seconds, go to minutes. There's 60 seconds in a minute, so divide by 60. What do I get? I got 1.52 minutes. So a minute and a half till the ball hits the ground below. That would be a long time waiting for the ball to hit. All right, let's do the next one. Number 12. Zelda stands at the top of a 500-meter high cliff. She throws a stone horizontally off the cliff at a speed of 18 meters per second. And we want to know everything. How much time passes until it hits the plane below? What's its horizontal velocity? What's its final vertical velocity? What's the final combined velocity at the moment of impact? Give it magnitude and direction. So this is just one of those I want to know everything kind of problems. So let us figure this out. And here we go. So picture, always helpful. Cliff. We're going to throw an object off the top of it. It's going to go whoop like that. It's 50 meters high. This is 50 meters high. And it's going to have a horizontal velocity of 18 meters per second. So let's take our two columns of information and see what we can find. On the horizontal side, what do I know? Horizontal velocity is 18 meters per second. Do I know horizontal displacement x? No. Do I know time in the air? No. Vertical side, what do I know? I know that it's going to drop a vertical distance of 50 meters. I know that this person's on Earth, so gravity is 9.8 meters per second squared. I know since it's being launched straight horizontally that its original vertical velocity is 0. I don't know the time, but I do know that those two times will be the same. Now, I am going to use the vertical information to find time. Once I have time, I can go back to horizontal and find that displacement. So let's go ahead and do that. So first thing I'm going to do is I'm going to find time. The equation we've used for lots of times on the vertical side is, we're going to use y is VOT plus 1/2 AT squared. And original vertical velocity is 0, so that goes away. We're going to do a little magical, fabulous algebra. Mary needs room to write. So time is going to be equal to 2 times y divided by acceleration square root of 2 times vertical displacement. Vertical displacement is 50 meters. Acceleration of gravity is 9.8 meters per second squared. How long is this thing going to be in the air? Grab my calculator. 2 times 50 divided by 9.8 equals square root, the little beastie, 3.19 seconds. That's the time that it's going to be in the air. That's one of the things we were asked to find. Another thing we were asked to find is what is its final vertical velocity. So I'm going to change pen colors. Final vertical velocity is going to be equal to original vertical velocity plus acceleration times time. Original vertical velocity was 0, so this is going to be 9.8 meters per second squared times the time in the air, 3.19 seconds. So final vertical velocity is going to be times 9.8. That is going to be 31.3 meters per second. This second's going to cancel one of the squares. We end up with meters per second. We now want to know horizontal velocity. Let's go back and find horizontal velocity. Horizontal velocity is going to be equal to displacement over time. And oops, we know horizontal. We don't know displacement. So x is going to be horizontal velocity times time. Horizontal velocity is 18 meters per second. We found the time. Let's go back and look at it so I don't make crazy numbers up. 3.19 seconds. So displacement is going to be 3.19 times 18 meters per second. 57.4 meters is the horizontal displacement. And then last but not least, they ask this question, which is a cool question. What's the stone's final velocity, combined horizontal and vertical motion, and the moment of impact? Now, here's what I'm asking. As if you were standing there with a little radar gun at the moment this thing went beep and hit into the ground. We want to know the velocity it's coming down at, and we want to know the angle of impact. Now, that final velocity right at that moment, when it impacts, is going to be a vector made from the horizontal velocity vector and the final vertical velocity vector. So the horizontal velocity vector has always been 18 meters per second. That was given in the problem. The vertical velocity vector is, where did we find it? It's 31.3 meters per second. So we're going to use that 31.3 meters per second. That's my vertical velocity. Here's my horizontal. How am I going to find this? Well, I'm going to use Pythagorean's theorem. So a squared plus b squared equals c squared. And to find the final is going to be, pick up my calculator here, 31.3 squared plus 18 squared square root. Final vertical velocity I ended up with 36.1 meters per second. But they asked for one more thing. They want to know the angle. How am I going to find the angle? The angle is found from this velocity vector triangle, where the horizontal velocity is the adjacent side, the final vertical velocity is the opposite side. If I have adjacent and opposite, I'm going to use tangent. The tangent of theta is the opposite over the adjacent. The opposite is the 31.3. The adjacent is 18. If I divide 31.3 divided by 18, that gives me the tangent. Then I've got to go second tangent or inverse tangent, and I end up with 60 degrees. And how do you say this 60 degrees? Because it doesn't have a compass heading. It's not north, south, east, and west. This is 60 degrees above horizontal. All right, that is a good problem and good preparation for our projectile lab.